Good morning, everyone. Thanks for coming to our March library series. It's the third of 5. And today we're really fortunate to have our Extension honeybee specialist, Dr. Garrett Slater. He's going to talk to us about the basics of beekeeping, and you're in for a real treat. So without further ado, I'll let Garrett take over.
Well, thank you. So, first off, my name is Garrett. I'm the new honeybee extension specialist. This is really a brand new honeybee program. I've only been here for about 9 months or so I moved to Tyler about 9 months ago. And so I'm really excited to start building the program from scratch. And so you probably met Dr. Andrew King already. We're kind of located in the same Overton facility. So if you ever go out there to visit him, you can stop by and see what we're doing at the Bee Lab. So this is sort of a new honeybee extension program, so I kind of want to give you an overview about it. I'm located in Overton, but my role is a statewide appointment. And so even though I'm located in East Texas and Tyler, I'm in charge of the entire state. So I'm really fortunate not to have to drive very far. I live in Tyler, so instead of driving all the way to Odessa, I'm going to drive like 5 minutes to the library. So thanks for the invite. But I've been kind of traveling across the state, trying to build an extension program, sort to get some beekeeper input about what they're looking for, and really start to develop the program goals for the entire state. We also hired 3 program specialists, and so these are regional program extension personnel. So we just hired somebody in Houston. She'll be in charge of the beekeepers in the Houston area. We just hired somebody in Dallas-Fort Worth that'll be in charge of the DFW area. We have somebody in San Antonio. And so we have pretty much a full team, about 4 to 5 people, to start building the extension program and start supporting beekeepers across the state. So one thing that we have is our Master Beekeeping Program. We've had this program for the past 10 years, but now it's under extension. And so instead of being under the Apiary Inspection Service, it's now under Texas A&M Extension. We're doing a lot of great work to really start developing this program. So if you are interested in beekeeping and learning about keeping bees, we have this full program. And so part of this program is sort of a 4-level program. Our apprentice is our first level. And so if you want to learn all the basics of keeping bees and managing bees, the apprentice is a really great first level. But if you plan on going farther into the program where you want to do some volunteering and supporting beekeepers, do more education, you can go on to the advanced master and master levels. So we do have a 10-week course, like an online virtual course. 10 weeks is 3 hours every Monday from February 10th all the way to mid-April. So we're already 6 weeks into that course, but everything's recorded, so you can either attend the live sessions or watch all the recordings. But this is basically like a 30-hour beekeeping 101 course. So if you do plan on getting bees, we highly recommend that 10-week course. Now we get into the fun part. So are there any beekeepers in this room, or people interested in keeping bees? Maybe a few, you guys have bees? Oh, not yet, you're thinking about it, okay. So here in the US, really across the world, beekeepers manage honeybees in these Langstroth colonies or these boxes. A Langstroth is a person that invented the bee boxes, and what that means is they have removable frames within the boxes. So if you actually open up those boxes, there's about 8 to 10 frames that you can remove. And that allows a person to inspect the colony, inspect the queen, and make sure the colony's really healthy. It also allows a beekeeper to remove those frames and extract any honey from the colony. So this Langstroth colony has really revolutionized beekeeping over the past couple 100 years. Now typically beekeepers manage them in these 2 deep boxes. So you look at the bottom, those are deep boxes. That's where the queen's laying eggs, that's where the brood is, and that's where the young developing eggs and bees are. Then as the summer progresses, beekeepers will add the boxes on top. They're basically the same boxes, just smaller, because as you can imagine, it's easier to pull off a smaller box versus a heavier box. It's really tough to pull off 200 pounds of honey, so it's easier to put those medium supers on. And so this is what typically a colony look like. They have the bottom box and the cover and things like that. So for a beekeeper, we have kind of 3 central things. So if you're thinking about starting bees, what type of equipment do you need? Obviously, you'll need to buy the boxes, the bottom boards, and the covers, but essentially you just need a smoker. So smoker is a device where you light up some kind of smoker fuel that produces a thick smoke, and you use that to smoke on top of your colonies to hide the alarm pheromone. Because one reason that bees may pursue you and sting you is because they produce alarm pheromone that alerts the rest of the bees to come pursue the disturbance, and they start chasing you. So when you open a colony, we smoke the bees, that calms them down, and makes it easier and I guess more enjoyable to get into the colony. Nobody likes to be pursued, so smoke is a really great way to mask that alarm pheromone. So if you start, you need a smoker. Second, you need a bee suit. I recommend buying more, and as you become more comfortable, you can use less protective material. So for me, I only use the veil. I don't wear gloves or full bee suit because I know my bees are really calm. They're really easy to work with. I really don't need a veil, honestly, because our bees are really great to work with. But as you're starting out and you don't know the behavior of your bees, you might want to wear a full bee suit, gloves, a veil, and boots, just so you don't have to get stung. But also, for me, I know I don't have an allergic reaction to bees, but some of you may or may not know if you do. So it's really important to wear more protection, and then eventually you can wear less. They also have like vented suits, so especially here in Texas, and this is one thing I'm learning, it gets really hot here, so wearing a vented suit is really, really helpful. And on the far right, you need a hive tool. It's basically a tool to open up the colonies, open up the boxes. So once you get started, you start reading bee catalogs. There's hundreds of different things you can buy, but this is the three things you need: a smoker, a bee suit, and a hive tool. So bee products, so why do people keep bees? Mainly for the honey. Honey is a sweet substance that people have been using as a sweet substitute for hundreds and hundreds of years. So one reason that honeybees were first imported from Asia, Africa, and Europe was due to their honey production, because back in the 1600s and 1800s, they didn't have access to a lot of sugar. So honey was a natural sweetener that they could get from the honeybees. So even today, we've all had honey from the stores, and honey's a really great sweetener and a great product for your toast or other things like that. Another product is pollen. Has anybody eaten pollen before? No, you haven't? It's kind of weird, but I think a lot of people eat it for their allergies, right? Some people think there's medicinal benefits of consuming pollen, especially in your local area. So one reason that people purchase a lot of local honey is because it has pollen in it, pollen from your environment, so you're kind of getting exposed to that pollen beforehand. And I think right now, there's kind of a bad pollen year, I've heard, compared to years past. And so one way, if you're having some sort of reaction to it, is by consuming honey or pollen from this area. So I think if you go to Brookshire's, like Fresh, they have a lot of local pollen you can buy, or you can buy the honey directly from the local beekeeper. And then we have pollination services. So especially here in Texas, honeybees provide really important pollination for, think about watermelon. They're important for increasing the yield of cotton. They're important for a lot of other crops. So pollination for honeybees is probably their most important attribute. But honeybees are also shipped across the entire country for pollination. So some are shipped to the Midwest for cranberry and blueberry pollination, or the East Coast. Some are shipped to southern Florida for orange pollination. But primarily a lot are shipped to California for almond pollination, because without bees, we wouldn't have almonds. So we always put out that number, like 1/3 of what we eat on the shelves is directly pollinated by honeybees. And we may think of like the other native pollinators and other pollinators, for example, but just due to the nature of how much food that we're growing in a large area, we need these commercially managed colonies to provide the important pollination. And so, we need to support not only native pollinators, but honeybees are important pollinators for a lot of these crops, not only locally here in Texas, but across the country. Okay, so honeybees are known, they have this development called holometabolism. And so what that means is their development is very similar to a butterfly. So they have this kind of larval grub stage, they go through metamorphosis and spin a cocoon, and they become an adult bee. Now we don't view them as butterflies, but they're very similar in that development. So if you look right here, it might be kind of hard to see in the back, but in the far right corner there's a picture of a honeybee egg. The egg's about the size of a grain of rice, so it's extremely small. The egg will hatch after 3 days and then become a larva. Larvae are basically just digestive tracts, that's all they are, because their goal is to eat as much as possible and grow as fast as they can to become adult bees. And so there's about 5 different stages of larvae. They go through these 5 different molts or instars. So as you can see, the small ones on the far right, those are about 1st or 2nd instars, all the way to 5th instars on the far left. And so every day, these larvae go through molt and get bigger and bigger and bigger. Once they reach their maximum size, they spin a cocoon, and then they're capped by the workers in these wax cappings. That allows the bees to protect the larvae, protect them from the environment, and make sure that they can actually go through metamorphosis and develop. So instead of having that clear cocoon like butterflies have, the bees basically make their own cocoon with this wax. Then after about a week or so, they emerge as an adult and become a new adult bee. Now this is all worker cells, so all these ones will become workers. But the drones develop in 24 days, which are the males. The queens develop in 16 days. And these workers right here will take 21 days to get from an egg to an adult. So these are the different castes and sexes within the colony. So typically one colony will have one queen. As you can see, the queen is quite a bit larger than the rest of the bees. And she has 2 largely developed ovaries. And she can lay somewhere between 1,000 and 2,000 eggs per day. And so she's the only one inside the colony that can actually lay eggs. And she'll do this for somewhere between 2 to 4 years, and even upwards of 7 years at times. So she's a really important member of the colony for her egg laying and the reproduction of the colony, and make sure, more importantly, that the colony is growing and thriving throughout multiple years. She also produces very specific pheromones. So as I talk about the communication with bees, one way that bees communicate within the colony is through these very specific pheromones or scents. So based on the scents that the queen gives off, that can tell the colony that there's an active laying young queen inside the colony. So it's one way for the bees to know that there's a queen, but she's doing a very good job. Because as that pheromone basically wears off, the workers may decide to usurp her, kill her off, and replace her with a new queen. Another thing she does is she adds a specific pheromone to the eggs. And so based on the number of eggs she's laying, she produces more pheromone, and that tells the rest of the workers that, hey, we need to collect more pollen, we need to collect more nectar to support that new brood. And so the queen's basically directly telling all the workers that, hey, I'm laying a lot of eggs, we need more food coming in. Third, she's really important for colony cohesion. So, I mean, one thought may be like, why aren't these like anarchy bees, right? Why did one worker just kind of go off and start laying on herself? Like, why do they need a queen? Because this queen's basically suppressing their behavior, suppressing their reproduction, so they don't become anarchy bees, right? So they're all kind of falling in line with the queen. So one thing you might see if a colony becomes queenless is, especially if they're queenless for a long time, one of the workers will become a laying worker. She can't lay fertilized eggs, she won't lay unfertilized eggs, but she can start laying eggs. And actually, if you look at the Cape honeybees in South Africa, the queen doesn't have the same suppression. So some of these workers will actually fly off and take over an entire colony. So that's one thing that's really unique to our European honeybees. So yeah, I'll just take a look at Cape honeybees, they're really interesting. In the middle we have the drones. In the honeybee community, these are the males. We call them drones for some reason. I don't know why, I mean they look like drones, I guess. But their only role is to fly out and find an unmated queen. So they don't do any role in the colony, they don't do any nursing, they don't do any foraging. They're basically the teenagers in the colony. They mooch out the workers for the food, they mooch out them for the warmth, and they're kind of useless other than finding an unmated queen and mating with her. So a colony will produce maybe 120 males during the middle of the summertime when they have a bunch of resources available. Those males will fly off and mate with an unrelated queen. At the end of the winter, the colony will basically evict all the drones, kill them off, and then overwinter without the males. So right now, there's not many males left in the colony because they've all been killed off, but once they start producing honey again, they'll start producing males again. Then we have the workers. Workers and queens are both females. So one way that a colony determines sex is by the fertilization of an egg. So a fertilized egg becomes a queen and a worker, so they're diploid, meaning they get genetics from both the male and the female. Whereas drones are unfertilized, and so they only get genetics from the queen, so they're actually haploid and get one set of chromosomes. So one way they determine sex is by this haploid-diploid sex determination system. So the workers and queens are genetically exactly the same, the result of a fertilized egg. But one reason that a queen becomes a queen and a worker becomes a worker is based on the food they receive during development. So the queens will receive about 2 to 3 times more food during development. That'll become a reproductive queen, whereas the workers are basically starved queens. they receive less food, they become, have shriveled ovaries, they have specialized features like a barb stinger, they have like larger legs like pollen, and become more specialized to non-reproductive tasks that needs to be the case for a worker. So why is the queen important, right? The queen's important for a lot of different reasons, mainly because she lays 2,000 eggs per day, and it's the only bee in the colony that can actually lay eggs. And so based on her ovary size, based on how many ovarials she has, that influences the number of eggs that she can lay per day. So her main importance is this egg laying. But two, her ability to mate with males and store that sperm for a long period of time. So the queen will only leave the colony for the first 7 days of her life. She'll fly out in a 3-mile radius and mate with somewhere between 15 to 20 males. After she mates with those males, she'll store it in a specialized sperm storage organ called a spermatheca. And then once she's done mating and stores that sperm, she'll never leave the colony again. And she'll use that sperm that she stored and lay fertilized eggs for the rest of her life. And so her ability to not only find years are around 40%. But this year is probably the highest in record losses we've experienced in, really the history. We're seeing like 70, 80% losses in California from beekeepers, and so these losses are really high. And so when we started to evaluate these colony losses, we just started to look for like what drives these colony losses. So you think about it as a beekeeper, these are the things you want to look for, and these are also the major reasons for colony losses. We like to call them the 5 Ps. We have parasites, which are the varroa mites that feed on the fat body of the bees, transmit deadly viruses, lower the immune system, and this is really the thorn in the back of a beekeeper because they've been around since 1987. We haven't found a good solution for them. 2, we have pathogens. So second P are pathogens. These include viruses. These include bacterial infections, fungal infections, things like that. Viruses are really hard because we don't have a way to vaccinate or treat for viruses. So if you have viruses in your colony, there's really not much you can do as a beekeeper. And most of them are transmitted by the varroa mites, so the best way to manage your virus levels is by managing your varroa levels. Number 3, we have pesticides. And so I'll talk about pesticides a little bit later on, but an insecticide is developed for a pest. And so any type of insecticide you're using, in most cases, those will be toxic to some effect to not only honeybees, but even native pollinators. And so insecticides can be really toxic to bees, but even fungicides and herbicides can have some toxicity. And then we have the 4th P, which is poor nutrition. And so as land's been converted from conservation, like CRP programs, for example, back into corn and soybeans and other agro crops, it's taking a lot of nutrients away from honeybees and even native pollinators or other pollinators. And then finally, poor queens. So I mentioned that queens are living 6 months when they should be living for 2 to 4 years. So think about why we see these high colony losses. We have these 5 Ps. We have parasites, pathogens, pesticides, poor nutrition, and poor queens.
Are certain of those 5, what's the best way to say it, which ones impact them the most, do you think?
Varroa mites for sure, varroa mites and the viruses, that contributes about 80% of the losses. I think pesticides maybe 10%, so it's not really that high. Then again, we can't measure the sublethal effects, it's hard to, but varroa mites are the biggest thing. But also for a beekeeper, this is something that you can actually manage, right? So some things like poor nutrition, pesticides, these are things out of your control. But with varroa mites and viruses, these are things you can control through like either breeding or management.
Are poor queens, is that from the environment?
We're not quite sure. It could be the males she's mating with, so maybe the males are really poor. It could be the mating quality, who knows? We're still not quite sure. It could be pesticides. One way to manage the varroa mites, like in this picture, is you apply a lot of chemicals into the colony, right? But it's really hard to develop a chemical that kills an insect, right? So if you apply an insecticide to an insect, it's going to have some kind of effect on the queens and the bees within the colony. So it's one thing that's necessary, but it could be impacting the queens too. Could be genetics, who knows? I wish I had an answer. Here's what a varroa mite looks like, a kind of red mite. You can imagine if you have like a dinner plate on your chest, that's how big the mites are relative to the bee. And so they've been around since 1987. They jumped host from Apis cerana, which is a species in Asia used for honey production, onto Apis mellifera, which are the bees that we manage. So ever since 1920, since they jumped host, They've been spreading rapidly across the entire world, and then made it to the United States around 1987. Fun fact, there's only one place in the world other than Antarctica, these people always mention that people actually live on that doesn't have varroa. Does anybody have any guesses?
Australia?
No, Australia 2 years ago, they finally got varroa mites.
Patagonia.
Sorry?
Patagonia.
No, not Patagonia. It's not too far from us.
Greenland.
Greenland has it. No, Newfoundland in Labrador. That's the only place in the world that doesn't have varroa mites currently. They have a plan. The rest of Canada has varroa mites, but the Newfies figured something out. But yeah, here's the varroa mites, and something that we've dealt with for a very long time. And like you mentioned, Australia, they first got varroa mites in 2022, so they staved it off for about 40 years. So here's the life cycle of it. So they jump on the back of the bees in this phoretic stage, and so this allows the mites to move not only within a colony, but between colonies. So one reason that varroa mites can spread really rapidly is because these bees can transfer them between colonies, and so if your neighbor has high mite levels, they can form mite bombs and spread to your colonies. But they kind of spread the back of the bees, they're feeding on the fat, they're kind of growing, and then they're really smart in that they jump into the cell right before it's capped. And so you see that far right picture of the cell entrance. This is about 2 hours before the cell is actually capped. So the mites are jumping in there because they're hiding from the workers that are trying to groom them and kill them, but they're also hiding from any of the treatments. And so that's what makes varroa mites really hard, is that they're hiding inside the cell wax capping. So it's hard to develop a treatment that's not only effective, but also goes to the cell cappings and kills the mites that way. So they start feeding once they're spinning cocoon. Then they start laying eggs, so lay male and 2 females. These siblings will emerge, and then they'll mate with each other, so they're really inbred. And then they'll emerge as a phoretic stage and repeat the process again. And so it makes it really hard to manage them when they're hiding inside these cells. These are different diseases and bacterial infections associated with varroa mites. One thing we often see is co-infections. So varroa mites are lowering the immune system of the bees, leading to some of these co-infections. This is a very common bacterial infection called European foul brood. It causes discoloration into the larva and causes them to die before they actually enter metamorphosis and become an adult. And so this is a really extreme case of European foul brood, but oftentimes when you have high varroa levels, you see a lot more of these bacterial infections. The only way to treat for this is through an antibiotic, but you can apply as many antibiotics as you want, but if you're not treating the root of the problem, which is varroa, it doesn't really make a difference. One thing we see is this brood disease. This is called parasitic mite syndrome. So this is a mixture of bacteria and viruses transmitted by the varroa, and it causes the larvae to become sunken down inside the cells. And so oftentimes when we see a colony crash from varroa mites, we see this parasitic mite syndrome with all the larvae die and the colony crashes within a couple weeks. There's not much you can do at this stage. Once you get to this point of varroa damage, it's sort of a point of no return. I maybe see 2% of colonies make it back from this, but it's nearly impossible. So as a beekeeper, you want to make sure that you don't get to this point. And then finally we have viruses. So the most common virus transmitted by the varroa mites is deformed wing virus. So you can see this worker is kind of grayish color and its wings are deformed. That's a clear symptom of this deformed wing virus. If you see one, there's probably more of these viruses within the colony because we're seeing less and less of these symptoms as this virus is rapidly evolving. As of right now, we have about 3 variants, but there's probably more and more variants evolving from this. But like I said, there's not much you can do once you have viruses. The only thing you do is treat your varroa levels and I guess hope the virus kind of leaves your colony, but we don't have a vaccine for it. So one thing we recommend to beekeepers is to monitor your varroa levels, once a month to know what your varroa levels are. And then 2, use our threshold of 3 mites per 100 bees. And then do not rely on visual observation. So if you do see a mite on the back of a bee, that's not an accurate way to measure your mite levels. These are kind of different ways of measuring the varroa levels in our colony. We have powdered sugar roll, alcohol wash, and CO2. And so what we basically do is we shake basically a half cup of bees into one of these devices, and then we can measure how many mites we have per 100 bees. So a half cup of bees is 300 bees, so you divide any of that number by 3, for example. So if one of these we found 9 mites, our threshold would be 3 mites per 100 bees, and so we'd be above threshold, we recommend a treatment. So one method is powder sugar roll. A lot of beekeepers like this because it doesn't kill the bees, but it's less accurate because if it's really humid in your area, the sugar tends to clump and your accuracy drops from 95% to 70%. And so you're relying on a threshold. It could be great to maybe save the 300 bees, but it's not going to be as accurate. The gold standard is the alcohol wash. So you can buy this device at any type of bee supply store. It already comes with a filter. You can pour like water with a few drops of soap. Windshield wiper fluid works, alcohol works. You pour a half cup of bees in there, you shake it for a minute, and then you see all the mites at the bottom, right there. So this one had a lot of mites, I mean about 50 or 60 mites. This one sort of had a point of no return. Once you start seeing these mites, it's hard for the bees to really recover from that. And we have a new method called CO2. Basically the same device, but instead of using alcohol, you knock them out with CO2. Now just remember that if you do plan on monitoring your mites, it's better to sacrifice 300 bees instead of sacrificing 20,000 bees. So I would recommend using the middle one. And just remember 300 bees are replaced every 2 hours, and so it's not going to have a huge effect on the colony. And it's better to be as accurate as possible rather than being inaccurate with these other methods. But as long as you're managing, that's all that matters. The best way to manage varroa mites is through having resistant stocks. And so one thing we're doing at Overton is breeding a honeybee that's resistant to varroa. So we can breed for bees that have increased grooming, so they actually find mites, chew their legs off. And we call this mite biting or mite hunting behavior. Another one is where the bees actually open up the cells. By opening up the cells, that disrupts the reproduction of the mites and causes the bee sterile or infertile. This is a trait called VSH. So we're selecting for these two traits to provide a resistant stock to beekeepers across Texas. Because the best way to manage them is by breeding. But then we have mechanical controls. So one thing you can do is actually take brood from the colony, freeze it, and kill all the mites hiding inside the brood. You can cage the queen, you can do things like that. We also have chemical controls. So if you're interested in learning more about chemical treatments of varroa mites, we do have our courses, but you should really prioritize resistant stocks and deprioritize the synthetic chemicals. Because one thing we're seeing is resistance to the hard chemicals. So there's other pathogens. So the first P is parasites, varroa. The second one is pathogens. So bees can have bacterial pathogens. So this is European foul brood. There's another one called American foul brood. We have fungal pathogens. This is called chalk brood. So you can actually see the fungal growth on the back of the bees. And then we have viruses, mainly deformed wing virus, but there's about 10 or 15 different viruses. So there's a lot of them associated with honeybees. Mainly transmitted by the varroa, but some can be transmitted during mating. So these are really the major pathogens that beekeepers have to deal with. Now, unfortunately, the only thing that we have a treatment for is European foul brood with antibiotics. The rest are sometimes kind of naturally cleared up if you don't have treatments for those. Okay, then we talk about pesticides. And so this is an example of a pesticide kill this past summer in San Antonio. You see piles and piles of dead bees on the bottom board, and these bees have their tongue sticking out, and they're kind of shaking and twitching because they're kind of paralyzed from the insecticide. And so the major reason for colony losses are, like I mentioned, the varroa mites and viruses, but pesticides can play a role. And typically when we measure pesticide-related losses, we see these massive die-offs. But the thing that pesticides have the most damage with are these long-term sublethal effects that are really more difficult to measure. So we talk about pesticides. There's 3 major types of pesticides. We have one, insecticides. Insecticides are directly developed for an insect, and so any type of insecticide you're using will have some sort of effect on honeybees and even other pollinators. So some are more toxic than other ones, right? Like neonicotinoids, which are systemic, can be toxic for long periods of time, but even like organophosphates and things like that can be toxic to bees. We have fungicides. Fungicides are sort of a mixed bag. Some fungicides are toxic, some aren't toxic. But what we know is that if fungicides and insecticides are used together, which they typically are, that can increase the toxicity of insecticides. And then herbicides. So I would say the majority of herbicides aren't toxic to honeybees or pollinators, because what they're doing is they're killing the weeds, they're killing those nutrients for the bees in the spring. And so herbicides are typically killing like dandelions, Dutch clover, and things like that, which are a major source of nutrients for not only honeybees, but native pollinators in the spring. And so most of their damage is by taking away a lot of those resources. But some herbicides can be toxic to bees, like glyphosate, for example, is extremely toxic to bees. Dicamba can be toxic. Some things like this can be very toxic to bees. So, but I would say the majority aren't toxic to honeybees. So one thing I always like to talk about is how to read a label. So you may be thinking about using some sort of chemical. So what chemicals can you use? The first thing to look for is sort of the bee label that tells you whether it's bee friendly or not. And so if it has a bee label and says it's bee friendly, this is something you can use for honeybees and won't cause any problem with other pollinators. But they do, if they are toxic to bees, knowing how toxic to the bees is really important, because in some cases you may have to apply a chemical, but you want to know how long that toxicity is for. So one thing we measure is that residual toxicity. So this residual toxicity tells you how long this chemical is toxic to honeybees. And what you're looking for is something that's toxic for less than 8 hours if you have to use this. Bees are toxic for less than 8 hours, you can apply it at night, the bees are still inside their colonies or inside their ground nest, and by the time they're emerging, that chemical is no longer toxic to bees. Now, they make these labels, I guess, as complicated as possible to make it kind of harder to interpret. But one thing you'd be looking for is, if it says actively foraging, those are the ones that are toxic for less than 8 hours. So that means if it says actively foraging on it, and you apply it at 6 p.m., for example, by the time the bees are actively foraging again, it's no longer toxic. So you want to look for the ones that say actively foraging if it's not bee friendly. If it just says foraging or visiting without actively in front of it, these will be toxic for over 8 hours. Now sometimes these will be toxic for a couple hours or a couple days, or be toxic for multiple weeks. So I wish they put like an exact time period for the residual toxicity, but they make it as confusing as possible. So I guess actively is good, not actively is bad. So exposure, where can exposure happen at? So public places and golf courses. As you can imagine, if you're maintaining a well-manicured lawn or golf course, it takes a lot of chemicals and management to maintain that perfect golf course. And so, one thing I see with a lot of beekeepers that are managing bees around golf courses, they tend to bring in a lot more pesticides and have a lot more pesticide-related damage. And so that's one thing to consider if you're managing bees, is to be farther away from these public places or golf courses, unless they have some kind of pollinator plan. I'm not sure about Tyler, since we're a bee city that changes their management. I have no idea. But certain cities, they don't have that bee city status and aren't practicing good bee management practices. But even if you're in an area where these well-manicured lawns, right, if you have a perfect lawn without any weeds, there's typically some kind of chemical being applied. And so even if you're managing a really great bee-friendly garden and you don't have this well-manicured lawn with a lot of chemicals, your neighbor could be. And bees are flying somewhere between 1 to 3 miles away, so you can't really control a lot of these factors. And then pest management, so we think about termite management, using fipronil, which is really toxic, cockroach spray, which is fipronil, is also toxic. So just know it means very necessary to control a lot of these pests, but these can have some kind of effect on bees. So these are two types of pest-related damage. We have acute toxicity and chronic toxicity. Acute toxicity is where you see direct damage by the bees, where one day you see really strong colonies, the next day you see piles and piles of dead bees from your colony. So these are the ones that beekeepers can measure, and you can clearly see the effects that pesticides are having on a colony. The chronic ones are a bit more difficult. This is where you see these long-term sublethal effects on a colony, but it's tough to know whether that's from varroa mites or pesticides. So the long-term ones, even though those are probably have the worst effect on bees, are the ones that are more difficult to see. So with the honeybee colony specifically, you see these sudden bee deaths. So you see these piles and piles of dead bees on the bottom board in front of the colony. On the video here, we see the bees have a back of their legs, and their legs are twitching. They're almost like paralyzed and unable to move. And then you see their tongue sticking out, like that. But the one thing you should note here is that honeybees are managed, and so it's easy for beekeepers to split those colonies in half and make up those numbers. Easy for them to move away from any spraying. But the ones that are probably getting the brunt of the damage are these native pollinators and the ground nesting bees, because they can't move, and the sprayers don't know where the bees are, for example. So even though I'm kind of showing pictures of the honeybees, those are the ones we can actually measure, but a lot of times the ones that have the most effect are the native pollinators or native bees. And so this kind of goes into the chronic effects. These are ones that I guess are harder to measure, but as you imagine that wax, the wax comb, for example, is a lipid. That lipid can absorb all these chemicals from the environment, right? Because most pesticides are hydrophobic. So this wax will absorb all that. So if you look at wax samples from a beekeeper from 5 years ago, you'll see hundreds of different residues in the wax because the bees are bringing that back in. Now, as you're bringing that pesticides back into the colony, it's stored in the wax for multiple years. That can impact the brood development, the queen quality, the fertility, honey production, foraging, kind of everything related to honeybees, especially if it is toxic to bees. So these are things that you can't measure, but probably have the biggest effect on pollinators. Poor nutrition, and so one thing I always tell a lot of people is the best thing you can do to help support pollinators is to plant a bee-friendly or pollinator-friendly garden. Now, I get asked a lot of questions like, is that making a big difference? Like, even if you plant a few flowers, that makes some sort of difference. And so, I'm sure if you have some bee-friendly plants, you see a bunch of pollinators or bumblebees on your plants, you're helping bees to some extent. Now, are you able to support an entire colony? Maybe not, but if everybody's contributing together, then we're supporting bees in general. So, I know with like HOA restrictions or your neighbor pressuring you that you can't not maintain a well manicured lawn, there's some bee type lawn mixtures you can plant. And so there's like bee lawn mixtures you can buy that have Dutch clover. And Dutch clover is kind of this white small clover that blossoms for multiple months. And so it allows you to mow your lawn every couple of weeks, but still have that kind of weed grow back up and provide bee forage. So it's one way that you can still kind of mow your lawn every couple of weeks, but still have bee forage for not only honeybees, but also native pollinators. But the best thing to do is to plant a bee-friendly garden if possible. So we're developing a resource, but you want to choose plants that attract bees, so not only honeybees, but also native bees. Specifically bumblebees versus honeybees, they prefer different types of plants. So bumblebees really like crimson clover versus honeybees liking that sweet clover and Dutch clover. You want to make sure these plants are blossoming throughout the entire year. So some are blossoming and provide nectar and resources in the spring, some in the summer, some in the fall. So possibly you want this to be blossoming throughout the entire year and provide resources throughout the entire year. You want them to be planted close to each other, so the bees don't have to fly 10 feet apart. You want them to be as close to each other as possible, just so they don't have to go very far for the resources. And then try not to use chemicals if possible, and if you do have to use chemicals, read the label. First, look for whether it's bee-friendly, but if it's not bee-friendly, look for that actively foraging or actively visiting label and apply it at night so it's not toxic when the bees are flying again. One thing you also do is, mulch. I always like to tell people that mulch is sort of like a pavement for bees. And so it's hard for, especially a lot of the ground nesting bees, which are 95% of the bees, to get into the soil. And so if you are using mulch, leaving kind of an area between the mulch and your grass so the bees can crawl under and form their nest underneath the mulch is one great practice. So as you imagine, if you have like a 1-inch thick layer of mulch, it's hard for the bees to burrow in and build their homes. And this impacts a lot of your native pollinators. And so one thing you can do is kind of leave an area, maybe dig up a little dirt so allow the bees to get underneath. One thing you also do is in the fall, leave twigs and leaves available so the bees can build their overwinter nests under those leaves. So there's different things that you can do to support your native pollinators. If you're interested in what plant to plant, the Pollinator Partnership has a really great resource. You can put in your zip code, and it tells you plants that can grow in your area and are beneficial to not only honeybees, but butterflies and native pollinators. So yeah, this is kind of summary of the 5 Ps, and so we have parasites, pathogens, poor nutrition, and so if you think about getting to bees, it's not going to be easy. It's hard to manage bees. They're sort of a managed livestock, so it does take a lot of work. I don't want this to deter you from managing bees. Just know that getting the right education, being prepared is the very first thing to do before you start getting your bees. And we have a lot of free resources online, so you have Texanium and AgLearn. We have a bunch of, we have a virtual beekeeping 101 course. It's a 4-hour course, it costs $45, and it gives you a quick primer on keeping bees and managing bees. So if you think about getting bees, that $45 course is a really great quick primer about what it takes to keep bees. And then we have a bunch of free fact sheets. So we have one on creating a pollinator garden. We have one on, bee equipment, general hive maintenance, purchasing colonies, things like that. And we're constantly putting free resources on AgLearn, so you can look for resources that way. And then we have our Master Beekeeping website, textmasterbeekeeper.com. We have our Facebook page, our agriculture extension page. So if you're interested in any class that we have in Overton or across state Texas, you can follow our Facebook page. And if you have any questions for me, you shoot me an email on my A&M email. And I think I have four minutes.
For questions?
Yes.
We lost one of our observation hives at the Goodman Museum last year. You know about it? To the
Yeah,
bee
it's
beetles.
moved from the Rose Garden to the Goodman Museum, right?
Right.
Yeah.
And we lost it within a month, like maybe 6 weeks. But they're going to put more bees out there this year. Well, what do you do to prevent that? Or is there anything?
Observations are really hard to prevent because, especially that one that you guys have, it only fits like 4 frames. So typically I have a smaller colony on the bottom, just so the colony can grow, because oftentimes if it's too small, it restricts the brood development, restricts the queens, so observation colonies just need a lot more care. So you want to see something that go out there every couple of weeks to make sure it's healthy and doing well.
They get that.
Yeah, I'm not sure who's managing it either. I think it's like a local beekeeper maybe, or maybe
We
it's...
got a new one this year. I don't know.
Okay.
Yeah. Okay.
Yeah, if you guys need any help, I'm happy to go out there and inspect it. And
Okay. Thanks.
like take a look at it and see how it's looking, I mean, I don't live too far away, so it's not too hard for me.
Okay. Great. Thank you.
Can you go back to that website that was like
The Pollinator Partnership?
Partners or something?
The Pollinator Partnership, yeah.
And it's pollinator.org.
Yeah, if you go to Google and type in like Pollinator Partnership, this will come up, and then I think they have like a tab for like pollinator gardens, and then you type in your zip code. They have one specifically for the southwest area. One resource I really like is the Pheasants Forever. They have really great pollinator mixtures that way. So if you do have a larger area that you want to invest into either CRP land or even now CRP, they have pollinator-friendly seed mixtures for both sandy and clay soil. So depending on where you live, they have a lot of great resources specifically for Texas.
Would that be where you would look for a turf mixture that would be friendly for?
Yeah, they might have a turf mixture. If you go to like bee lawn, I know that I think Scott's sells like a bee lawn that has the Dutch clover in it and the crimson clover. So if you go Google maybe bee lawn, it'd be nice to develop one specific for Texas. Definitely has more Midwest. And as you see with lots of bee forwards specific for the Midwest, there's not much research down in the southern part of the U.S.
Is there any, when I was younger, I used to look at a lot of bees, and every once in a while you see a bee where the stripes are across its body. They'll have a stripe down the middle. We call them AIDS bees. We know they don't have a stinger. They won't sting you. You know anything about that? Or?
So it's like a stripe that goes kind of along the
Yeah,
body.
most of them are this way, and once in a while you find one on top where it's got that line between the two. These call them AIDS bees, and they don't have a stinger.
I'm not sure. Yeah, I'm not sure what kind of bee that is. Yeah, I mean, it wouldn't be a honeybee. Yeah, because honeybees always sting. But it's probably like some kind of solitary bee species, I'm guessing. Right? Do you know if it's ground nesting?
No, they were.
They're just flying. You saw them. Yeah, I'll look into that and see what it is. Do you have a question?
I was going to ask about the foraging time. So say like if you get your yard, mosquito spray, when mosquitoes get bad, and then what time do they go out and forage, like where so you can say, hey, don't spray my yard until this time or that time?
Yeah, typically the foraging ends probably at least 5 p.m. and then they start foraging again probably 8 or 9. But typically you'll have a mosquito flogging. It's only toxic for about 4 hours. They're required to apply it at night, and so by the time the bees are foraging, I never seen bee losses due to mosquito baiting or fogging. I think a lot of people think there is, but I haven't seen much from it.
Oh.
So as long as you're applying it at night, it's only toxic for 4 hours typically.
Oh.
Any other questions? I don't want to take too much of your time.
No? That was great. Thank you.
You can go back
I learned so much, and I need to hear it over and over. The repetition is good. Thank you for speaking to us, and just wanted to let everyone know, Smith County Master Gardeners does sponsor this series next month. Our speaker will be Dawn Stover. She is a study leader agronomist for the USDA NRCS at East Texas Plant Materials Center in Nacogdoches. She is going to be, and I want everyone to note that the third Friday is Easter, is Good Friday. So we had to move this to April 25th. So it's actually, I think, the fourth Friday of April. So it's April 25th, and we also had to move not only the date, but the time. So this will be from 1 to 2. Seating will start at 12:30. And our presenter will be from 1 to 2. So the name of the presentation is Gardening for Worms, Host Plants for Butterfly Caterpillars. So she has developed that for this area, and so it should be a good presentation. I encourage everyone to come back. This is a free program in partnership with the library. So please do that. And then I have a couple of announcements, and then we have one from someone in the audience. But the Smith County Master Gardeners host a home garden tour on Saturday, May the 17th. This year we have 5 beautiful private gardens, all within the Tyler's city limits, that will be showing off their spring finery. So please look for that. We have save the day cards on the back table, and you can sign up for that. We have a Jot Forms sign up so that you can pay, and it costs $21 at the door, but there is a bit of a discount if you sign up ahead of time. Also, starting this weekend, in Tyler is the Azalea and Spring Flower Trail. We have some brochures for this. There are many activities going on in the area that you might want to take advantage of. I'd like to just draw your attention to 2, starting tomorrow on March 22nd and the 29th, and also April the 5th. We will have Master Gardeners in the Tyler Botanic Garden, which is part of the Tyler Rose Garden. And if you have questions or want to know more about the plantings in the 3 gardens that we maintain, please come out and take advantage of that. Also, on March 25th, we have a privately led garden tour of the Pyrone Garden, which is a really famous garden in the Azalea District. Dr. Greg Grant will be hosting that and taking about 20 people through the gardens to look at all of the beautiful plantings there.
What date did you say,
The 25th. It's this coming Tuesday.
Well, only 20 people can come.
Yes, it's a small garden.
We advertised it on Facebook.
Yes.
It doesn't say that.
Well,
You might want to retract that advertisement then.
well, I mean, if we get more than 20, we can make some arrangements for that,
And what
but
time is he hoping to be there?
10 o'clock. And did you want to talk about the Iris Society in Dallas?
I didn't expect to speak today, but I appreciate the program. I'm retired here in Tyler from Dallas. I still have a membership in the Irish Society of Dallas. And I'd like to invite any of you that want to. Our show is the 12th of April. There's no entry fee. You can bring as many irises as you like. And get some ribbons if you're the winners. The second thing I want to talk about is we have a fundraiser third Saturday of September. All irises from bearded iris to Louisiana iris. We even have some Japanese iris, which are really difficult to grow in Texas. All of these are coming out of members' gardens, so they've grown well. We have members from West Texas to the Red River, to Tyler, and as far south as Cleveland, so our membership has a lot of geographic area within Texas. But anyway, we dig them with our doorman. The third Saturday of September, 9 a.m. we open. It's a nice day trip. Come and go shopping for irises. They're $10. They're dug, trimmed, cleaned, and ready to plant at your convenience. $10 no sales tax. We only do this once a year. We'll have a couple hundred varieties. Of course, out of volunteer gardens, we don't know exactly what's coming until a couple weeks before the sale. But we do put all the pictures of what we're selling on our website. Unfortunately, we don't have a lot of technical people in our club, so the website is not the greatest. So bear with us. We'll have pictures up a couple weeks, let's say September 1st to the first week of September. So you can shop online, bring your lists, and we'll help you find what you'd like to have.
And it's at First Christian?
It is in the same church we've been in for about 5 years. It's west of Galilea, 1 mile south of LBJ on Marshall Lane. It is in northwest Dallas. It's a nice day trip. Come go shopping, have lunch in a new restaurant, and be back for dinner here. We will have about 1,000 plants, maybe a little more, going historically, a couple hundred varieties from the 1800s up to relatively new. And I think you'll be shocked. I was on our website a couple of weeks ago, and the pictures from last September are still up. So if you go to irises, plural, -dallas.org, or just look for the Irish Society of Dallas, you can look at pictures that's fairly representative of what we sell every year. Thank you for the time.
Thank you. And just a word, we do have evaluations. If you wouldn't mind filling that out, it's fairly painless and it helps us plan for our next year of topics, and it helps our AgriLife department and our speakers. So really appreciate your attendance today, and thank you for your interest in our programs.